In this video, I'd like to show you my Honeywell DDP-516 emulator running on a Windows 10 PC. The DDP-516 was a 16-bit mini computer which was very popular from the mid to late 1960s. And in this emulation, at the top of the screen, I can set the screen size in case you're using a screen which has different dimensions from the one I'm using here. And below that is an emulation for the ASR33, the teletype, a device that was commonly used with the 516 for input and output. And anything coming from the keyboard of the computer will go into the 516 as if it's coming from the keyboard of an ASR33. And anything the 516 outputs to the teletype, that's octal address 4, will appear in this area of the screen. And below that is a representation of the 516 control panel. But I'll come back to that in just a moment. When we wanted to load programs into the 516, we mostly did it with paper tape, and so it was important to have a high-speed paper tape reader, and this is emulated at the bottom of the screen. And these paper tape readers often ran at 500, 1000 or even 2000 characters per second. And at 2000 characters per second, the tape whizzed out of the end of the paper tape reader and stood in the air for about a metre before falling to the floor, and the tapes very easily became tangled and damaged. However, this is an electronic emulation of a high-speed paper tape reader, and so we're using a computer file which contains an image of the paper tape, and the load button is like closing the gate on the paper tape reader. And to output programs to paper tape, we had a high-speed paper tape punch, which is emulated here. We have an on-off button for the punch. And now back to that all-important control panel. This was a 16-bit computer, so we have 16 push buttons for entering bits into any of the registers. And they've been divided into groups of 3. This is because we generally worked in octal. Today, most computers use hexadecimal as a numbering system, but back in the 1960s, octal was very important and very often used. And we can set bits in registers just by pressing these push buttons. And we can clear the register by pressing the clear button at the end here. And we can select which register we want to view with these register select buttons. The left one, register X, the index register. This is the only register we can't change from the control panel, because it's permanently linked to location 0 in the main memory, and we can only change it by changing the contents of location 0. Then we have the main arithmetic register, register A, the secondary arithmetic register, register B, the program counter, register P, and the memory register, register M. And to the left of those buttons we have 4 sense switches, which we can set and reset, and these can be tested by programs to set various options. And to the right is the master clear button. Pressing this initializes the machine and clears all the registers except register X. And to the right of that there would normally be the power fail interrupt, power fail halt switch. However, we don't need it in this emulation, so we use it as fast, slow, medium speed for the emulation, where medium is about the speed of a real 516 and fast is faster even than a 716, which was a later version of the machine. And to the right of that is the fetch and store button, the PP+1, and then the 3-position memory access, single instruct and run switch. And to the right of that, the start button, which lights up when a program is running. Now, if we wanted to load programs into the 516, we used something called a key-in loader. This was a program that was permanently in the memory of the 516 in location 1 to 15 decimal or 1 to 17 octal. And this small loader program could not be changed from any programs inside the 516. It can only be changed from the control panels. So let's have a look at it. If we're in the program counter, we put 0, which we've done by doing master clear, and set fetch and P+1 in memory access mode, then when I press start into the M register, we will see the contents of location 1. And it says 010057, which is the first instruction of the key-in loader. And then the next one, 030001, which is the input-output OCP command to start the high-speed paper tape reader, and so on through the key-in loader. Okay, let's do master clear again, clear all the registers. And let's put a paper tape into the paper tape reader. And I'm going to put into the paper tape reader CMT5, which is the memory test program, and I'm going to press the load button and it says beginning of tape. Now with everything cleared with master clear, I'm going to go into run mode. I'm going to put into the program counter 1, the start of the key in loader, go to run mode, and when I press the start button, the key in loader will start running and begin loading the tape. And I said this was a fast paper tape reader. It's even faster than that 2000 character per second reader, and so it didn't take long to read in the tape. Now I go back to memory access mode, do a master clear, and I set the program counter to 1000 octal, which is the start address of the memory test program. I go into run mode, and when I press the start button, the memory test program will begin running. And on the ASR33 teletype it says AB16 CMT5 June the 7th 73 revision E. The CP is a 516, and it's now testing the memory. It's a fairly quick program. There's 16K in this machine. It says pass 1. Locations 1673 octal to 37,777 tested. That's 16K. Now the program has relocated itself to the top of the memory, as we can see by the program count, and it's now testing the bottom part of the memory. And it says pass 2, location 21 to location 36,117, and now it's relocated itself to the bottom again and is testing the top of the memory. So let's now stop the program, and that's the memory test program. I'm doing master clear all the registers, and I'm going to change the program in the paper tape reader to CCT4, the instruction test program, and press the load button. We're at beginning of tape, put 1 in the program counter, start of the key in loader, go to run mode and load the instruction test program. This is a larger program, will take a little bit longer to load, but it's still very fast. Now we go to memory access, do a master clear, and again this program starts at 1000 octal, so bit 7 in the program counter, and I go to run mode and start. And it says AB16 CCT4 April the 24th 73 revision H, sense switch to AREG 8 times. It wants to test that the sense switches work and can be tested by the program, and it will show the results in register A. So I set sense switch 1, and when I press the start button, the machine is already running. So this will cause something called a start button interrupt, which the program will see, and it will then look at the sense switches. And it sees sense switch 1 is set. And now 1 and 2, 1, 2 and 3, 1, 2, 3, 4. And now I'm going to reset them. And every time I press the start button, I get that start button interrupt, and it checks the sense switches. And now the program says done, and now it's going on to test all the other instructions of the 516. Now this takes quite a little while, so I'm going to put the machine, it does say it's a 516 with 16K of memory, which is correct. I'm now going to put the machine into fast mode, so that this runs somewhat faster. And it says pass 1. And so it's tested all of the instructions of the 516, and I'm now going to put the machine back into normal medium, so 516 speed. And then I can go out of run mode, master clear, and that's the end of this demonstration.